rectangle has an area of 80 square inches. Could you set me up an equation based on the picture and knowing the area was 80 square inches to try and solve for x? Frank, what do you think? Good deal. Okay, 2x times x minus 6 equals 80, right? Just like length times width. I could reverse that, but that's probably the best way to write that. I don't know why I just put 0, pretend I put 80. Okay, now just do a little distributive property. That's what's going to create the quadratic here. When I multiply 2x times x, then it's becoming 2x squared. So there's my quadratic. 2x times negative 6, negative 12x, and that's equal to 80. Now, we're going to try and review completing the square, so we're going to solve this by completing the square. So right now, as it's set up, this is good for us because we've got our squared term and our linear term on the same side already, so I don't really have to move anything. Would you do anything here maybe before you tried to complete the square? Would you do maybe anything? Yes. Do you see how all these terms are even? Let's just get rid of 2 real quick. Just divide everything by 2. And this will make it perfect because we don't want a number in front of our x squared term, which if we do this, we don't have that anymore. Okay, now, what I'm going to do as I write this, let me leave a little spot to complete the square. So after I write the negative 6x, I'm just going to leave a little spot so we can complete the square. The other side, we're going to have 40, and then I'm going to leave a spot to complete the square. Now, does anybody remember from yesterday, like, how do I find the number to put in that little spot? Yes, b value divided by 2 squared. So, if you want to write that little magic number, b value divided by 2 squared, your b value is just the coefficient of your linear term. So negative 6 divided by 2, then I must square that. So negative 3 squared, which is 9. So on the left side, that gives me a perfect square trinomial, which means if we put it in factored form, both of the factors are the exact same and we can squish it together. On the other side, I also have to add 9 because that keeps my equation balanced. So I'm manipulating the left side to get myself 2 factors that are the same. So I have to do the same thing to the left side and the right side of that equation. Now, just to remind you from yesterday, because some of these questions are going to get a little bit gross with some fractions today, whatever you square should be the factor with the, or the number in the x with the factor. So when I write this in factored form, should just be x minus 3 squared. And 2 numbers multiply give you positive 9, add to give you negative 6 would be negative 3 and negative 3. Now on this side, this is actually nice for us because 40 and 49, or sorry, 40 and 9 is 49, and then that is a perfect square. So we're going to take our square root, and whenever we introduce the square root, don't forget it has 2 answers. It could be plus or minus. The square root of 49 is just 7. And to get the x totally by itself, I got to move this 3. So I'm going to add it to the other side. And sorry, I'm writing too big. I didn't leave enough room. So I'm going to have x equals 3 plus or minus 7. Now, if that's 7i, done. If that's 7 radical 2, done. If it's just the number 7, you can actually add that to the 3. So this is 3 plus 7 would be 10, and 3 minus 7 would be negative 4. All right, so if we think back to the original problem, are both of those answers to this question? Why not? Exactly. Okay, now, you cannot have a negative length or width or a negative area. So this guy has to go because if I plug in negative 4, 2 times negative 4 would make the length of that negative 8, or negative 4 minus 6 would be negative 10. So that would give me a negative length. I don't want to always tell you to exclude a negative number because it depends on what the expression is that's in the picture. But in this case, if I plug in negative 4 to either side of that, that's going to make a negative length and a negative width. So in terms of that equation, it has 2 answers. In terms of our problem, x would just be 10. And then just to tell you guys, I feel like the Math Excel question might ask you to find the dimensions. So if it asks you to do that, you can just plug it back in real quick. So like the length would be 2 times 10, so it would be 20, or the width here would be 10 minus 6 would be 4. So if they ask you for the dimensions in the question on the homework assignment, all you have to do is plug that back in. But don't plug in the -4 because that gives you negative length. Okay, is anybody having a question? Okay, I gotta have you do me a favor. I'm gonna change this first problem so it's because I've gotten some people with some really garbagey stuff on their math Excel. So I'm just gonna cross this question out and change it so hopefully it'll be more similar to what you'll see on the homework. Alright, I'm gonna write 3x squared plus 8x minus 3 equals 0 instead of what I had there. Alright, now the two questions in this example are similar in that they have an a value that is not 1, but these are going to practice some different skills here. And I'm not going to lie to you, we're going to work with some garbagey stuff with some fractions in these two questions. So you cannot complete the square if you have a number in front of the squared term, which I do here. So I'm going to do one thing just real quick like we did yesterday. If you have a plain number, so I have a constant of -3, I'm just going to move that to the other side of the equation. And I only want to deal with the quadratic term and the linear term, so the x squared and the x on one side. So I've got 3x squared plus 8x. I'm not going to leave a space to complete the square at the moment. Let me show you that in a second. Equals 3. Okay, now this one's going to be weird. So if your a value is not 1, what you need to do is divide only the left side of that equation by whatever your a value is. So I'm going to take and I'm going to divide a 3 out of both of these terms. The reason this is extra tricky is because that linear term, that 8, is not actually divisible by 3. So when I write this, it's going to look like a fraction. So I'm going to pull 3 out in front. This will make the quadratic term just a 1x squared. Now, because 8 is not divisible by 3, and I can't reduce that fraction, that 8 over 3 will actually be the b value. And you're going to see this on a problem probably on the Math Excel, unless you get some unique situation. But hopefully you guys can see, if I multiplied 3 back through there, that would cancel the 3 in the denominator and give me back 8x. So it should just be a fraction just like that. And then I am going to leave a little space to complete the square, but I'm just going to complete the square inside those parentheses. Now on the other side of the equation we had 3, and then I'll have to keep my equation balanced, so I'll have to add something to the other side, just like I'm going to do to complete the square. Alright, so a couple skills here. First of all, my b value is now a gross fraction inside here. So it's still the b value divided by 2 and squared. Do you guys know what happens if I divide a fraction by a number? Like, do you know what that would be? What would 8 over 3 divided by 2 be? Frank, do you know? It's 8 over 6. Okay, I don't know if you guys know this. If you divide by 2, it's the same thing as multiplying by the reciprocal 1/2. I always just remember, if you divide a fraction by a plain number, so 8 over 3 divided by 2, these guys get multiplied together. So this becomes 8 over 6 squared. Now, if you want to, you can absolutely do this in your calculator as well. So I could literally type it in. Just do 8 divide by 3 divide by 2. It'll have 2 division symbols. And then I would do my math, enter, enter. And the reason I actually want to write this down, I got 4/3, which is 8 over 6 reduced. The reason I want this is because if you guys remember from yesterday, whatever you square is in the little factor with the x when you write the factored form. So it's really good to go ahead and write that, keep that as a fraction. And I know that's a lot because it's kind of a nasty number. But I'm just going to square 4 and I'm going to square 3. So to complete the square, I'm going to add 16 over 9 to both sides. Okay, now here's the trick to this question today that's different from what we did yesterday. I'm not really adding 16 over 9 to this side. Does anybody know why? It's not really 16 over 9. What am I really adding to this side? What do you think? Say that one more time. Not the reciprocal. Brody, what do you think? Exactly. Okay, so really what I'm adding here, because I have a 3 out in front of these parentheses, is 3 times this. So you don't have to write this on your paper, but what I really added to this side is whatever 3 times 16 over 9 is. If you take a number multiplied by a fraction, you could do this in your calculator if you want to, do 3 times 16 over 9. Make sure you put the 16 over 9 separate. Otherwise, the question will do 3 times 16 and then divide the whole thing by 9. So we want to make sure, multiply it by that fraction. And then you can do your math, enter, and that'll be 16 over 3. That's really what I multiplied, or that's really what I added to that side, because I'm taking whatever's in front here times what I put in those little set of parentheses. Some of these questions are easier than others, but really what I added was 16 over 3 when I put it in that set of parentheses. Okay, once you're there, this is very, very similar to yesterday. The only difference is I'm going to have a 3 in front of my parentheses. So, as promised, whatever you squared, we squared 4 over 3. That is going to go in my factored form. So it would be x plus 4/3 squared. And if you wanted to sit there and FOIL that out, like x plus 4 over 3 times x plus 4 over 3, it will give you back what I have in those parentheses. It's just a little bit tricky to work with because of the fraction, but I promise that is the factored form of that. On the other side, I'm going to grab my calculator and I'm going to add 3 to 16 over 3. And I'm going to do my math, enter, so I can write it as a fraction. And you're going to get 25 over 3. And I know this looks garbagey, but it's going to get better, don't worry. So I'm not going to distribute, I'm going to divide by 3. When I do that, if you take a fraction, we did a similar problem, or similar part to this problem. If I divide a fraction by a number, these two, the denominator and what you're dividing by, just get multiplied together. So this is really x plus 4 over 3 squared equals 25 over 9. And that's super nice for us because when we take the square root of both sides, both of those are perfect squares. So I will have my plus and minus, but the top, the square root would be 5, the bottom, the square root would be 3. And it's just a nice fraction, and it's got a common denominator with the 4/3 that I'm going to have to move from the other side. So we're going to subtract 4/3. And x is going to be negative 4/3 plus or minus 5 over 3. Now, I can actually add both of those together and add and subtract because those are common denominator. So you would have negative 4 plus 5 over 3. And you'd have negative 4 minus 5 over 3. Negative 4 plus 5 is 1, and keep the 3 on the bottom, so 1/3 would be an answer. Negative 4 minus 5 is negative 9 divided by 3. That's actually a nice number, not a fraction, negative 3. So my two solutions there, I know that's a lot of work. So 1/3 would be an answer, and negative 3 would be an answer. It's just kind of keep track of what you're doing with the fraction, and feel free to use your calculator to help you on that to speed the process up. Is anybody having a question? Okay, now, the other one here. So this is going to be a little bit different skill. Alright, so I've already got it set up so it's got the quadratic term and the linear term on the same side. I've got 2x squared minus 8x equals 1. First thing you have to do, if you don't have a plain x squared to start your quadratic, you have to divide by whatever the a value is, which is just going to be 2 here. I'm only doing this on the left side of the equation. You don't have to do it to the right side. So I'm going to have 2, then we'd have x squared minus 4x, and then I'm going to leave a space to complete the square. The other side of this would just be 1 plus whatever we're going to add to help us complete the square. Excuse me. Alright, so grab your b value in the parentheses, so negative 4 divided by 2 squared, which is negative 2 squared, which is going to be 4. So I'm going to put that in the parentheses. Sorry. I'm going to put that in the parentheses to complete the square in the parentheses. What did I really add to that side of the equation when I put that 4 in there? 8. So I'm adding 4 times 2, because there's a 2 out in front of this, so this is 8. The 8 comes from the fact that this 2 would be distributed to that whole set of parentheses, so the 8 comes from multiplying 2 by what I added in there to create the perfect square, so that's why that's 8. Once you're there, this is pretty quick, so 2, whatever you squared, that should be in with your factor, so we squared negative 2, so x minus 2 squared should be the factored form of what's in the parentheses. The other side's just 9. Now, initially I was like, oh cool, but it's not a perfect square because I have to divide by 2 before I take the square root. So this is going to be a little bit different skill. I want to see if you remember from Algebra 1. I have x minus 2 squared equals 9 over 2. And they unfortunately don't end up with a perfect square in the denominator of that fraction. We can take the square root of the top of that fraction. So I have x minus 2 plus or minus, square root of 9 is 3, so I could simplify the top. And then the bottom, I can't take and break down the square root of 2, so it would just be square root of 2. Alright, is that okay for me to have a square root of 2 in the bottom of that fraction? Do you guys remember? Does anybody remember how to get rid of the square root of 2? Because we're not allowed to have a radical in the bottom. Exactly, exactly. This is called rationalizing a denominator. You don't have to know what it's called, but whatever the denominator is, just copy it. And whatever you do to the bottom, you do the same thing to the top. I know this looks really weird, but we're really just multiplying by 1 because it's something divided by itself. So I'm not changing the value of the expression. If you do this, I'm going to just write this to the side here. This would be on the top. It'd just be 3 roots of 2. And you can skip this step if you understand this. But square root of 2 times square root of 2, we're going to squish those together. That becomes the square root of 4, which creates a perfect square, which creates the radical being canceled out in the denominator. The square root of 4 would just become 2. So that's the whole purpose of that. Completely fine to have a radical in the top, just not in the bottom. All right, so I know that's a lot. So I had x minus 2 equals plus or minus 3 roots of 2 all over 2. The only other thing I can do there, this just has a really garbagey looking answer, and that's just how it is. The only other thing I need to do is get that subtraction of 2 away from the x. So I'm going to add it to the other side, and you can just leave your answer right like this. 2 plus or minus 3 roots of 2 all over 2. And that's just the answer. If we looked at this on the graph, it's going to cross at those weird decimals if you wanted to figure that out on your calculator or something, but it's just not a nice answer today. Does anybody have any questions? Alright, I'm going to have you do one more of these. And this one I did not nicely set up with the quadratic and linear term on the same side. So I'm going to have you do one thing before I take anything apart here. I'm going to move the 20. Just going to subtract it real quick. So I want the quadratic term and the linear term on one side. Any other plain numbers, just move them to the other side of the equation. So sorry. Alright, so I've got 1/2 x squared minus 2x equals negative 20. If we want to try and complete the square, you cannot have a number in front of the x squared other than 1. It has to be just a plain x squared. So what I got to do here, I got to divide everybody by a half. So I'm going to pull a half out in front here. Have x squared. What am I going to get if I take negative 2 and I divide that by a half? This will be 4. If you want to do that on your calculator too, but if you take 2 and divide it by a half, it's the same thing as multiplying by 2. So this is minus 4x here. Then I'm going to leave my space, or a little space to complete the square. We got negative 20 plus, again, I'm just going to leave a little space to complete the square. I have a 1/2 out in front of the parentheses. So when I complete the square, I have to think about what am I really adding to both sides. So this actually, I feel like we had the same number on the other question for a b value, but it's negative 4 divided by 2 squared. So negative 2 squared, which means I'm adding 4 in that set of parentheses to complete the square. Since I have a 1/2 in front of the parentheses, what did I really add to that left side when I put that 4 in there? 2. Half of 4 is really 2. So if you're not sure, it's just whatever's outside the parentheses times whatever you added in there. Half of 4 is 2. So that's what I really added when I put that in the parentheses there. Now, once you're there, hopefully you remember whatever you squared, that's your factor. If you have a hard time thinking about it, should just be x minus 2 squared. Now this side is going to be negative 18. What would you do maybe as your next step? There's a couple different ways you could do this. Like if I want to get rid of 1/2, how can I get rid of 1/2? Yeah, I would just multiply by 2. I would cancel the 1/2 out. So we get x minus 2 squared. Now negative 18 times 2 is negative 36. And this will be very nice for us because we're going to take a square root, and negative 36 is going to give us a nice answer. What would you write as the square root of negative 36? Frank, go ahead. Plus or minus 6i. Now, the only other thing, I got to move the 2. So I'm just going to add 2 real quick, but we don't have to do anything else because we can't combine that with the 6i. So you just write your answer. It'd be 2 answers. Plus and minus counts as 2 answers, 2 separate answers, just a shorthand way to write it. So you have 2 plus 6i and 2 minus 6i. Is anybody having a question? Okay. Now, there is a purpose to this. You guys have converted from standard form to vertex form before. Maybe don't write this down, but I'm just going to remind you. We just did, like from standard form, negative b over 2a to find the x-coordinate of the vertex, and then I had you plug in negative b over 2a to find the y-coordinate of the vertex, and we knew that the a value was the same in both forms. You can also put these guys in vertex form by completing the square. I have to show this to you because I get all the kids in pre-calc have to do it this way. They're not allowed to use negative b over 2a. So I got to show this to you, and this is a really, really good skill when you guys start work with conic sections. You'll do parabolas, ellipses, hyperbolas next year. You use this process to find the center. So I'm going to show you guys this process with just a parabola. Okay. Very similar to what we did, the main difference. This is not set equal to 0, it's set equal to y. So what I would have you do, I'm going to move the plain number, just like we were on the other questions, to the other side of the equation just for a second. So I'm going to write y minus 5, and then x squared plus 8x, and I'm just going to complete the square on the right side of that equation. Now, the way I set that up just over there, whatever I add to that side, I'm going to have to add that same thing to the other side of the equation where I have the y minus 5. So I'm just going to leave it like that. Now, because my a value is 1, we don't have to worry about any multiplication or whatever. We're just going to do negative b over 2. Or we're going to do b over 2. I don't know why I just said that. We're going to do b value divided by 2 squared. This is going to be 4 squared, which is going to be 16. Now, I'm adding 16. I'm adding 16. I don't have any parentheses. I'm not multiplying by anything. So straight up just adding 16 to both sides to keep that equation balanced. On the lovely left side, you can actually add 16 to the negative 5. So this is y plus 11. Now, this side, whatever you squared, that should be your factor, which was 4. So the factored form of what I have there should just be x plus 4 squared. And then all you have to do to put it in vertex form is just move that 11 back over to the other side. That's actually going to be the y-coordinate of the vertex. So vertex form here, x plus 4 squared minus 11. If they were to ask you for the vertex, you could do your opposite copy. So it'd be negative 4, negative 11 would be the actual vertex, but the vertex form would be the equation. Is anybody having a question? Okay. Now, I'm going to do the same thing with this guy. Let me add any plain number. I'm just going to add it to the other side with the y. So I have y plus 3. Now this one has a little bit of a trick to it because my a value is not 1, it's -1. So you do have to take a -1 out of the quadratic term and the linear term here. Probably if you saw this in a book or something, they would just put a negative symbol. I'm going to go ahead and put a -1. Now, left over, that turns that into positive x squared, which is what I want. That would turn that linear term into minus 6x, and I'm going to leave a little space to complete the square. And then I'm going to go and I'm going to put plus a little space to complete the square on the other side, so we'll keep our equation balanced. Take your b value, which ends up being -6 here, divide by 2, and we're going to square that. So I'm going to have -3 squared, which is 9. What did I really add to the right side of that equation? -9, because I'm really doing -1 times 9, so this would be plus a -9, or you could just do -9, but really what I did there, when I completed the square, I subtracted 9. So on this side, go ahead, put 3 minus 9, so it would be y minus 6. Like I said, they'll probably just put a negative symbol, not an actual -1. Factored form of that would be x minus 3 squared. And then all you got to do to put it in vertex form, I'm just going to add the 6 back to the other side. So y equals negative x minus 3 squared plus 6. And if they ask me for my vertex, opposite copy, the vertex there would be 3, 6. Here is my vertex form. And then just to separate the vertex there. The last two are a little bit trickier because we have a number in front of the x squared that is not 1 or -1. So this is a little bit tricky. I'm going to move the 7. Any plain number, just move it to the other side for a second with the y. And my linear term and my quadratic term both have to be divided by the a value, so it'll start out with a plain x squared. So to do that, I'm just going to divide by 3. Now, what would be left over? We'd have just an x squared, which is what we want. -12 divided by 3 is -4. And I'm going to leave a little spot to complete the square. And then I'm going to put that on the other side so I don't forget. Take your b value, which is, I feel like we've done this on like 4 questions today. So it's -4 divided by 2 squared, which is -2 squared. You don't have to write this out if you understand where this is coming from. I'm just trying to show you. This is 4. So in the parentheses, I'm going to add 4 to complete the square. What did I really add to this side of the equation? 12, because it's 3 times 4. This is 12. I guess I should be writing this. So if I take 3 times 4, that's why I'm putting 12 there. Alright, all you got to do, just add the numbers on this side, so y plus 19. On this side, 3 is just in front of the parentheses, and then whatever you squared, that should be your factor, so x minus 2 squared, and then I just have to move that y coordinate back to the other side. So to do that, I'm just going to subtract 19, and it just goes outside the parentheses. So this vertex form, you'd have 3 times x minus 2 squared minus 19. My lovely vertex, opposite copy, would be 2 -19 if they ask you for the vertex. Alright, and I've got one more. This one's kind of nasty when we get going on it. I'm going to move the plain number first. So if you've got a constant term, just move it to the other side with the y. So I'm going to write down y minus 3. And then what I'm going to do here, I got to divide my linear term and my quadratic term. If there's an a value that's not 1, you got to divide by that. In this case, it's going to be -2. So I'm going to have a -2 out in front. And that would change my quadratic term to x squared. That's what it should be every time. That's what you want it to be. Now this is why it's tricky. The middle term here is going to become -5. So we're having an odd b value, which is going to have us working with some fractions on this problem, sorry to say. So take your b value, and I like to write it out especially if it's an odd number. -5 divided by 2 squared. You cannot reduce that. That's going to be what's in the factor. You can square it though. This is going to be 25 over 4. So that is what I'm going to add. Now, what I really added, because we have this -2 out in front here, is whatever this number is times whatever you put in there. So this would be -2 times 25/4. And if you want to do that on your calculator, I'm totally fine with it. What it should do, it should just make the top of the fraction change. The bottom should stay the same. So this would be -50/4, which I can reduce that. Both of those guys are even. So this is really -25/2. So really I added a negative number to this side because of the -2 out in front. Now, all I'm going to do is use my calculator, all right? So I'm going to do I'm going to use -3 and then minus, I'm just going to put this in parentheses, 25/2. And then I'm going to do my math, enter, so it'll give me a fraction there. So on this side you've got y minus 31/2, just means the y coordinate of my vertex is a fraction. Fabulous, I'm not asking you to graph it. The factored form of this, I swear to you, whatever you squared, that should be the factor. So the factored form, this should be x minus 5/2 squared. And I just need to move that 31/2 to the other side to get that y by itself, and then you're in vertex form. Whatever you square always goes in the factor with the x if you did that correctly. And this vertex is just kind of a garbagey number because it's fractions, but it would be, opposite copy, 5/2, and then 31/2 would be the vertex if they ask you for the vertex. The vertex form is the actual equation, but if it asks you for the vertex, it's asking you for the h and k. Is anybody having a question?